are going to start a new series which is specifically made for the ICSE board students. And here we are going to address the very renowned book ML Aggarwal. We will try to solve each and every question step by step, and at the same time we'll try to understand the concept which is applied in that particular exercise. So without any further delay, let's start. I hope you all are aware with some number systems. We know that the first number system that we have is of natural numbers starting from 1 to infinity, right? And when we include 0 to it, the new number system becomes whole numbers, right? And later on, when we add the whole numbers, at the same time the negatives of natural numbers, this number system is called the integers. Also, we know that all the integers can be written in the form p by q, right? Considering the q is not equal to 0 and p, q, they all belong to integers. This such form is known as rational numbers, represented by q. And in this whole exercise, we are going to discuss that between two rational numbers, for example, between a rational number 1 upon 1 and 2 upon 1, there exist infinite rational numbers. And how do we find it? So let's start with this exercise. Moving to our question number 1, the question states, insert a rational number between 2 upon 9 and 3 upon 8, arrange in descending order. Before we find out any number, we need to ensure that we know the descending order, and for it, which number is bigger from the other one, that we need to check. And for this, we will be using the concept of comparison. 2 by 9 and 3 by 8. I hope you know how to compare the numbers. It's like multiply the denominator of one number to the numerator of another number. You'll be getting 16 here. And here 9 3s are 27. I hope you know that 27 is greater than 16. Therefore, 3 upon 8 is greater than 2 upon 9. Right? Now, how to find a number between them? We just need to find one rational number. How to do that? Because they are demanding for only one rational number, we will be using the mean or average method. 2 upon 9 plus 3 upon 8. Add both the numbers and divide it by 2 using the concept of average. Now, you need to take the LCM of 9 and 8, that is 72. Then multiply 2 by 8 and 3 by 9. Then divide it by 2. Later you will be getting 16 plus 27 divided by 72 multiplied by 2. Once you solve it further, you will get 144 in the denominator and 43 in your numerator. So now we have complete solution for this question. So our answer would be, the smaller number is 2 upon 9, and then we found the number between them, 43 upon 144, and then the greater number here, that is 3 upon 8. Since we are writing in descending order, we have arranged greater, then the middle number, and then the smaller number. Let's move to the next question. The next question is, insert two rational numbers between 1 upon 3 and 1 upon 4 and arrange in ascending order. We will use the same concept again. First, we will compare the given boundaries 1 by 3 and 1 by 4. Multiply, you will be getting 4 here and you will be getting 3 here. We know the 4 is greater. Therefore, 1 upon 3 is greater than 1 upon 4. First thing is solved. We know that which number is greater than other number. Now we will find out two numbers between them. How to do it? For that, first thing, you take your number 1 upon 3 and 1 upon 4. Take their LCM. The denominators 3, 4 and their LCM would be 3 4s are 12. Convert your rational numbers with denominator 12. It would be 1 by 3 multiplied by 4 and this multiplied by 4, then and 1 upon 4, this time will multiply by 3. Our boundaries are 4 upon 12 and 3 upon 12. However, we are not able to find out two numbers between them. So in this case, now we will multiply our both the boundary rational numbers by 3. Why am I taking 3? When they are demanding for two rational numbers, take plus 1, that is 3. If they are demanding for 5 rational numbers, you can multiply by 6. We are just taking it for the convenience so that we don't lack of numbers as much as required here. So let's write 4 upon 12 and multiply numerator as well as denominator by 3. At the same time, for other part, 3 divided by 12 and multiply it by 3. You will be getting 12 by 36 and 9 by 36. You can easily see that the two numbers will be 10 by 36 and then 11 by 36, and a larger number which was 12 by 36 can also be written as 4 upon 12, and a smaller number 9 upon 36 can also be written as 3 upon 12. Since they asked us to arrange in ascending order, so we have arranged from smaller to bigger. Okay? Yes. Move to the next question. Our question number 3 is, insert two rational numbers between minus 1 upon 2 and minus 1 upon 3, then arrange them in ascending order. To arrange them in ascending order, first we are going to compare these two numbers. How to do that? Minus 1 by 3 and minus 1 upon 2. Compare the numerator and multiply it by denominator. You will be getting 2 here and you will be getting 3 here. Right? In this case, because these are negative numbers, we will be considering that minus 1 by 3 is greater than minus 1 by 2. Perfect? Now, arrange it accordingly. Minus 1 by 2 and minus 1 by 3. We will decide the boundaries like this. Next step, take the LCM of denominators 2, 3, that is 6. Now, what you need to do is convert the denominators into the form of 6 and multiply the first rational number by 3 and the second rational number by 2. This way, you will be getting minus 3/6 and minus 2/6. Because we are not able to figure out any two rational numbers directly, so we are going to multiply by 2 plus 1, that is 3 in both the cases. Multiply by 3 here and at the same time multiply by 3 in the second rational number. You'll get minus 9 upon 18 and minus 6 upon 18. Right? And now when you are writing your answer, it would be minus 9 upon 18, the smaller number, and then minus 8 upon 18, the greater than that, minus 7 upon 18, and then minus 6 upon 18. Also, you could convert the first two boundaries into their real forms, which are nothing but minus 1 by 3 is what? Minus 1 by 2. So, minus 1 by 2 greater than minus 8 upon 18, greater than minus 7 upon 18, and this is minus 1 upon 3. This is how you reach to the answer of question number 3. Now, moving to question number 4. The question number 4 states, insert 3 rational numbers between 1 by 3 and 4 by 5, arrange them in descending order. We are already aware that first thing is the comparison of numbers. Multiply the numerator of one number to another denominator, that is 5 here, and in this case it is 12. Since 12 is greater, we will write 4 upon 5 is greater than 1 upon 3. Now, how many numbers we need to find? 3 numbers. Therefore, 4 upon 5 and 1 upon 3. Take the LCM of these denominators, that is 15. Now, convert your rational numbers in such a way that their denominator becomes 15 and 1 multiplied by 5 and 3 multiplied by 5. you'll be getting 12 upon 15, and here you'll be getting 5 upon 15. In this case, we know that there are three numbers between 5 upon 15 and 12 upon 15. So we are actually not going to multiply by 3 plus 1, 4. There is no requirement of it. Okay? So we'll simply write our answer, which is to be in descending order. The highest number is 12 upon 15, and then it's 11 upon 15. Then it is 10 upon 15, 9 upon 15, and we will take the last boundary number, that is 5 upon 15. If you convert them properly, your final answer should be 12 upon 15 is what? 12 upon 15 is nothing but 4 upon 5. Then 11 upon 15, 10 upon 15, 9 upon 15, and the last number is 1 upon 3. That's it. So this will be your final answer. Moving to next question, that is question number 5, part 1. We need to insert 3 rational numbers using the concept of decimals between 3 and 3.5. So this is very easy. If you write 3 as 3.0 and the boundary line, that is 3.5, you can get your answer easily. It would be nothing but 3.1, 3.2, 3.3, and that's it. Okay, moving to the next, second question. Again, we will be using the concept of decimals, and we will find 4 rational numbers between 1 upon 4 and 2 upon 5. Because we have to use the concept of decimals, only that's why we are converting 1 by 4 into their decimals, that is nothing but 0.25. And we are converting 2 by 5 as 0.4, or you can write 0.40. You can use the proper division method and can convert a rational number to its decimal form. That's how your answer would be like 4 rational numbers are required. We can write 0.26, we can write 0.27 and 0.28. We can also take up to 0.39. And that's it. This is your answer number 2 of fifth question. Moving to third part, 5 rational numbers between 1 whole 1 by 2 and 1 whole 3 by 4. How to do that? 1 whole 1 by 2, that is a mixed form of a rational number. We'll convert it into proper form, that is 2 ones are 2 and plus 1, 3 by 2. When you convert it into its decimal, you'll be getting 1.5. Okay? And the next number, that is 1 whole 3 by 4. When you will convert this, you'll be getting 7 upon 4. And while converting this into decimals, it would be 1.75. Can I also write 1.5 as 1.50? So it will be easier for you to find out the answer. So our answer would be 1.51, 1.52, 1.53, and let's take a few numbers near about 1.75. It's like 1.73 and 1.74. Okay, and this is your answer. Moving to the next question, question number 6. Find 6 rational numbers between 3 and 4. How to do this question? Very easy. First, note down your boundaries and convert them into rational number by writing 1 in their denominators. Since the denominator is same, no need to take LCM. Just multiply both the rational numbers by 6 plus 1, that is 7, because they are demanding for 6 questions. 3 upon 1 multiplied by 7 each here, and then 4 upon 1 multiplied by 7. That's how you'll be landing up on 21 upon 7 and 28 upon 7. Therefore, your answer would be 6 rational numbers are required: 22 upon 7, 23 upon 7, 24 upon 7, 25 upon 7, 26 upon 7 and 27 upon 7. Exact 6 rational numbers between 3 and 4. Okay, moving to the next question, that is question number 7. Find 5 rational numbers between 3 by 5 and 4 by 5. Note down your boundaries. They are already in their rational forms, so we will check the denominators. Yes, the denominators are also same, so no need to take the LCM. Just see how many numbers you need to find. 5. So we will be multiplying 5 plus 1, that is 6 in each case. 3 by 6, this is 5 by 6, and here it is 4 multiplied by 6 divided by 5 multiplied by 6. You will be getting 18 by 30, and here you will be getting 24 by 30. When you are noting down your final answer, it would be 19 by 30, 20 by 30, 21 by 30, 22 by 30, and then 23 by 30. Exact 5 rational numbers between 3 by 5 and 4 by 5. Moving to the next question, that is question number 8. The question demands for 10 rational numbers between minus 2 by 5 and 1 by 7. Okay? Note down your boundary lines, minus 2 by 5 and 1 by 7. Since they are already in their rational form, okay, done. Let's check their denominators. No, they are not same. So take the LCM of the denominators. 5, 7, that is 35. And when you will solve it, you need to multiply the first number by 7 in numerator and denominator, and the second number by 5 in numerator as well as in denominator. You'll be ending up with minus 14 upon 35 and 5 upon 35. You need 10 rational numbers. And we can easily see that one number is negative, another is positive, and there exist so many numbers. So instead of multiplying by 10 plus 1 is equal to 11, we will simply figure out the numbers between the given boundaries. It would be minus 13 upon 35, minus 12 upon 35, minus 11 upon 35, minus 10 upon 35, minus 9 upon 35, minus 8 upon 35, minus 7 upon 35, minus 6 upon 35, minus 5 upon 35, and you can take like 4 upon 35. Up to 5 upon 35, you have to take from there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rational numbers between minus 2 by 5 and 1 upon 7. Okay? Moving to the question number 9 of this exercise, that is, find 6 rational numbers between 1 by 2 and 2 by 3. How to do it? First, again, note down your boundaries. Since they are already in their rational forms, first we need to find out the LCM to equalize their denominators. What will be the LCM of 2, 3? That will be 6. Awesome. Now, multiply the numerator and denominator by numbers so that the denominator of both the rational numbers comes in a sync. It will be 3 upon 6 and 4 upon 6. However, we could see that there are no numbers exactly shown here when it is 3 by 6 and 4 by 6. And we need how many? 6 rational numbers. So in this case, we need to multiply by 6 plus 1, 7 in both the cases. When you will do this, you will get 3 by 6 multiplied by 7 by 7 in numerator and denominator, and here 4 by 6, and this is 7 by 7. Your number is now 21 upon 42 and 28 upon 42. When you will write your answer, your numbers would be 22 upon 42, 23 upon 42, 24 upon 42, 25 upon 42, 26 upon 42, and the last would be 27 upon 42. And that's how we conclude our all 9 question of exercise 1.1 from book ML Aggarwal. Thank you so much.